Hey guys, this is the final part in my 700 tutorial series, which will be using a sprite background. I won't be teaching you how to make a sprite background because frankly, yeah, as you can see, this is the code for the sprite background and it's just a big mess. Um, so I'm going to be giving you the code to make it work so that you don't have to go through this big mess. But we'll be using a sprite background for our game and we'll be moving to VS Code. So back when we made our previous project, let's go here to our fourth program, an 8-bit workshop. But 8-bit workshop doesn't support extra hardware for the 7800. So we're gonna go to here, and I'm mainly just gonna explain to you how bank switching works because frankly, once you figure out how it works, it is very simple and easy to understand. I don't need to exactly demonstrate how it works. But the first thing I want to show you is why you should use a sprite background instead of going the easy way out. You'll notice that this game is very colorful compared to our previous games. So let's go back. So if you remember, with our previous programs, we have a limitation of 4 colors per zone. So let's see if this game aligns with that. So on this zone with the clouds, you'll see we have blue, dark gray, light gray, and white. Okay, that aligns with it. Next zone is the same. It's just more clouds. This third zone, um, has just blue. This fourth zone has only 3 colors. It has blue, red, and tan. And as you can see, we're gonna keep going. This zone has dark gray, light gray, and white, and blue. This zone has purple, light blue, white, and regular blue. Well, it's purple. Purple, cyan, white, and blue. But this zone has white, blue, and dark green and brown. But hang on, this zone has ignoring the sprite because it wouldn't count. We have blue, red, tan, green, white, gray, and dark gray, and also brown. That is 1, 2, 3, 4, 5, 6, 7, 8 colors. Where that's a lot more than 4 colors. Um, that's double 4 colors. And even here, we can see the rock and the vines. And overall, it's a lot more colorful. And the reason is simple. Instead of having a tile map background, we're having a bunch of sprites. So another advantage to this is on a console like an NES, you can only have 4 palettes for the background and 4 for sprites, but the Atari's palettes are all global, and you can use all 8 for anything. As you can see, I made 2 different levels for this. Besides physics, you can't interact with anything though. And just generally, it's as you can see, it's not perfect, but I made 2 levels. Um, and as you can see, there's a few glitches, but in general, this is just a lot better. I wanted to make a Legend of Enemy 2 game. I want to at some point. However, before I could finish it, I got busy. So this is the advantage. This is why you want to use a sprite background. So before we can do that, though, this game also uses bank switching. Um, so before we can do that, um, first make sure you have Atari Dev Studio installed, and second off, let's make our new program. So as you can see in my previous attempts, make a new folder. Call it your VSCODE 3. Um, select your folder, and you'll see it's blank. So we'll just do our main.asm, and let's just copy our program over. So you would think that by just copying our program over and saving it, that it will work. Or if you try, um, there's nothing. There's nothing here at all. Now, why is there nothing? Um, Now, as you can see, we only copied over our main, and we didn't copy graphics files. So you're gonna want to copy over your. Don't forget to copy over your graphic. I'm not gonna show you the scrolling background because you've already seen this program. Graphics. Paste it, run it again, and another thing you'll see is that this does indeed support multi-line comments. So don't forget to close that. And our little graphic does appear, and it does work. So if you're here, that means that your environment is working. As you can see, one of the limitations of my graphic system is that, when the sprites, you can't have sprites on the screen. There just doesn't support that. So you can make that work, and if I wanted to, I can actually make a game like Legend of Naomi work. In fact, I already partially did in my previous tutorial, where you can start the game, or you can't start the game. Because I made this wrong. Um, don't forget, Ape Workshop likes to use .a, and this likes to not work. Um, well, I made it work earlier. But that's not important. You've already seen Let It Randomly work. So let's go back into our VSCODE tutorial. So again, this is just our little project here. And to make sure it's working, I'll be including these in zip files. So instead of having multiple files, you'll just have one in a zip file. Um, so I made some other programs. Here is, if you go back, source files. Here's our multi-sprite 128K. And this is what I'm going to be using to demonstrate how bank searching works. So, bank searching on the Atari is very simple. You have, um, until recently, the standard for bank searching was always 128 kilobytes. They were kilobytes, but it was usually 128 kilobytes. And so you'll see this bank here. And just bank search, you simply write to bank. You can't read from bank. You can only write to bank. Bank can be anything from hex 8000 to hex BFFF. Um, and here's all my other variables, all my other stuff. Here's Pokey. If you've ever programmed an Atari 8-bit computer before, you'll know how this works. Um, I'll get into that later. And so what I like to do also for bank searching is have this little data bank. I didn't do it here, but I would have done it elsewhere. I like to have a little. I like to have a little data bank so that when you're bank searching and calling things in different banks, you know what bank to go back to. So we can see where I'm storing the bank. So I can store 0. So another thing for formatting is that the last bank is always the one at the bottom. In this header, this number is important as it's your hex value for the total size of your file. This stuff down here tells you what sort of stuff you want, like extra stuff. You can delete this. We don't need it. Um, any extra hardware you want. Pokey, the Pokey ones are putting Pokey at different spots. This one, when combined with EXRAM, is a bit strange, so don't do that. Um, unless you need to, but you shouldn't need to. EXRAM M2 is halt banked RAM, so you can have 32 kilobytes. Bank set is doubling your cartridge size. So if it was 128 kilobytes, now it's 256 kilobytes, and the extra 128 kilobytes would just be used for graphics because the halt line is on the cartridge. Super is a super duper awesome version of Super. It gives you all these cool things and gives you an ARM chip. Kind of like, DPC games on the 2600. Well, this is the DPC equivalent on the 7000. And it was popularized by Ricky and Vicky. The YM2151 is the arcade sound. Um, I like to point to 1942 for a good example of this. But anything which sounds like a Sega Genesis has this in it. Pokey again, Absolute and Activision are just weird banking systems used by Absolute and Activision. I won't get into those because they're non-standard. Um, Ixram A8 is what you would use if you wanted like rescue on Fractalus and you didn't want the whole um you didn't want to have to update a lot of graphics, so you can double your graphics height by doing something like this. Xram X2, I'm not sure what this is. Xfix is the second to last bank at hex 4000 hex 7FFF. So if you want 120 kilobytes but you don't want EXROM or EXRAM, then you need to have EXFix. EXROM is 144 kilobytes. EXRAM is 16 kilobytes at that area. Super Game is bank switching, standard bank switching. They've been coming up with some new methods for bank switching, but this is the standard. It's been the standard since 1986. And Pokey, um, and this is just Pokey again. Your controller type, TV type, it won't affect the emulators. Well, except for the PAL bit. Um, this is your safe peripheral. Um, external IRQ source. Make sure this lines up with this. And mine it's not any sort of slot pass through device. So something like for an example of this would be a 32X on Sega Genesis. And don't change any of this. Don't change any of this. Or this is just your title. As you can see, I got a bit desperate. um, so back to bank switching. The way it works is very simple. Just write to bank. So if I change it, here's with value of 1. And now we just have lines instead. If I change it to 2, did I put something at this? I didn't. So yeah. And if I change it to 7, 7 is the fixed bank. So the bank at hex C000 FFFF is the last bank in the set. And there's nothing there. So that's how bank switching works. I like to have a data bank because the idea is, let's just comment out this code. Let's just say we wanted to, for example, blah, blah, GSR code in bank one. We don't know what bank we're in, right? So let's just say you want to do a long jump routine. So you would want to know what bank you were previously in so that when you do an RTS, if you're in bank, if you try to bank switch, so let's just say your enemy code is in bank one and your so So let's just say enemy in bank 1 and your sprite graphics in bank 2. If you don't, so you're in this bank because you're executing your enemy graphics, but your sprite graphics are in bank 2. Well, you're gonna be, well, Marie's gonna see your enemy graphics, so you're gonna have a bunch of garbage on the screen unless you bank switch back to bank 2 before that graphics gets displayed. So that's why I would have something like a data bank variable, so that when you RTS out of your enemy handler, it will know what bank your graphics are in. Or for example, if you're saying your player code in bank 3. Well, if your player code's in bank 3, but let's just say your enemy handler in bank 7. Fixed bank. So your enemy handler is in this fixed area after coming out of your player code. Well, it's gonna try to jump to enemy routines in bank 1, but if you don't have a data bank variable or you don't switch to the correct bank, then it will just execute garbage and crash the whole system. Same for if it was sprite graphics or something like that. So make sure that you switch back to the correct bank afterwards. Um, so for example, let's go back to the Legend of Enemy 2. Yes. Um, go back up here. So as you see, your data bank. Now I used 6. So as you can see, before I JSR to my title screen because it's in bank 5, I made sure to store 5 to bank. And as you can see, this is where data bank comes in handy. Because when I'm trying to do something like this, you'll see that I have to load bank 5 for my music and bank 6 for Naomi. But I don't know what bank I'm in beforehand because, who knows? I might need to be in a different bank. I found out later that I usually didn't need to be, but it's always good to do that because if you want to have extra graphics in that volatile area, and if your code starts to lag and doesn't change it in time, then you'll just see garbage on the screen. Kind of like when you have a Super Nintendo game or Super Mario World and you bring Yoshi into areas he wasn't supposed to be in, you'll notice he shows up as garbage a lot of the time instead of the correct graphics. So it would be the same here. And this game also uses EXRAM to render its tile set so that you can have animated tiles. Um, so back to Pokey. Um, I'll be using the Atari again, not about 8-bit Workshop, but for the sake of simplicity, copy your Atari 5200 code over. Yeah, I got a little bit crazy. I tried to make a fan game of Murder Drones on the 5200 once. This is what Pokey sounds like. There's better examples than my screen. Here's here's an example of now as you can see I have 4 voices, but 2 of them aren't being used. Um, but that's generally what Pokey sounds like. Pokey, um, the main thing you need to do with it is first you need to make sure that skctl is a non-zero value and a non-ff value. Zero is init, and ff will cause everything to be silent. Um, It'll pause it. So if I go back here to music, it's taking a bit to load. If I open main, it takes a bit to load. As you can see, nothing, you can't hear anything, but change to one. That's good. Can't hear anything. But if it's I'll be linking this program too. So let's copy this. Actually, not that. Let's copy this instead. And just go back. So I'm actually gonna open a folder. This, go back here. It's your time for background. The reason I was called this was because it was a scrolling version of the um, not a new folder, my bad. New file, layer 2, music. And here's that. So, and don't forget, when you try to run this, it will run the file that you're looking at. So you always want to make sure that you're running the right file. Um, so the way this works, I'll get to explaining this in a bit, so you can add music to your game. The idea is simple. You'll have your music on the Pokey and your sound effects on the TIA, so that if a user who doesn't have a Pokey in their multi-cart or doesn't have Poke support tries to play your game, they'll still have the sound effects, so they'll still be able to play the game normally, just without music. The other thing I noticed is that if you set this bit, this is for Poke at 450. If you set this bit, and you try to play your game, that it doesn't, you notice it doesn't work. Now, I know this is this, but if you do compile it, and don't run it in the emulator and then open up A7800 elsewhere. So if I open it up here, for example, like directly, and then I run the file, it will still work. So don't be turned away from that black screen. It's just a glitch. And it might not, and it might be specific to my code, but I find it does that elsewhere too. But yeah, so this is so this program, I'm gonna be giving you this this is just your little example. All this is scrolling back and forth. It doesn't update anything or do anything fancy. Um, include Legend of Miami 2 as well, but I gave you some tools. So here's my music. Here's my music editor. Now the thing is that there's no proper editor for this, so you're just gonna need to know how it works. If there's demand for it, I will make an editor. So the way this works is quite simple. Every song every song has a start and a loop. So the idea with the start and the loop is that the start, you'll start your you will start your song and have it starting from here. But if you just wanted an intro, you would put the intro pointer here and then add the regular song and the start of the regular song here. I wasn't using that in this case though. Um, so the other thing is that setting a song is pretty easy. Um, no music is no music. So music init, A holds the song ID. So in spite of being called init, you can load a value to A, and that value will be used. and it supports up to 32 songs. However, there's a simple modification you can do to make it support all 256 songs, and that is by getting rid of this bit and then changing each of these to be song pointers, song loops, and song pointers one, song loops one, song, you know, you get the drill. Um, I didn't do that here because frankly, um, I don't I didn't think I needed 256 songs. After all, this is for Legend of Naomi. I didn't expect I'd have I didn't expect I'd have more than 16 songs. Um, but the way this works is pretty simple. Um, hex 0000, so 4 00s, will tell the system that it needs to load in new information. AF is the starting AUDCT AUDC value. 10 10 is the starting, I believe it is the starting, let's see. Something that I like to do is when I don't remember what things do, I will edit them here. So if I change this to a different value, like FF, as you can see, that is the pitch bend, or the that's the volume bend value, and this 10 here, well, I'm not sure exactly what it does. Oh, this is just notes. So this should actually be like this, but the same, and then 3 zeros in a row, or 6 zeros in a row, if you're looking at hex values, will tell the system to go back to the loop value. So again, 2 zeros, or 4 zeros in this case, will tell it to read in your new starting AUDCTL value, with the first nibble being the sound type, and the second nibble being the volume, and then this will tell it how quickly or slowly it should go up or down in volume. Now, just like the 2600, the volume registers are only 4 bits, but this music engine artificially makes an 8-bit volume register, so you can have more gradual fades of up to 4 seconds to fade out. For this, the first byte is just the pitch value, and the second byte is the length of the note. So that's how this works, and you can easily implement this into your game. It does require 32 bytes of your zero page, but you can move this out of zero page, some of this, except for these pointers. These pointers have to be in the zero page, but none of this has to be. So if you need to move this out, you can. But it will slightly slow down your program. Oh, and yeah, um, remember, I'm assuming you know 6502 assembly, but in case you don't, zero page is fast access. But yeah, um, it's pretty easy to get, it's pretty easy to get this working. Um, I know I had it working in this game, The Legend of Naomi, so I can change this to 800. Now here, oh yeah, one more thing. Here it's designed so that the difficulty switch will tell it to, one of the difficulty switches will tell it to not play music. So, so as you can see, my little music player is indeed part of our loop here. Um, so, so for example, um, so moving into 800, and then we need to configure it to be 800. Now, you'll notice that you don't hear anything. So if we try to do something like this, for some reason difficulty switches have their own menu. It's the right difficulty switch. So you can easily enable or disable your music using the difficulty switch. And the game still works without music. And this does not affect the TIA whatsoever. But yeah, that's how music works. So I'll be attaching this game as well as as well as as well as this, which has which is just our little, and I'll attach one more thing, which is going back here to our source files. I'll include the It's Years Time 4 background so that you can get started with your sprite background. So before I go, I should explain how the sprite background works. It's just a bunch of sprites, right? They're all 4-byte sprites. Um, you can change it by routing directly to this color chars. This is the color of each character. Um, so that's how that works. So hang on, lit char. So you'll notice our blit char. It supports 256 characters. Um, Now this reads out of random. So for this program to work, you need to have your character set at hex 4000 to hex 5FFF. You can remove this part and have 128 characters instead. You can also change these values to change where the character set is located. But my reasoning for why you should put it in RAM and not ROM is because that way, if you've ever seen well, this game doesn't use it, but if you've ever seen if you've ever seen a game, go look up Sharopolists, pushing the limits on the NES videos. But if you've ever seen something which doesn't clearly have the screen split up into multiple sections vertically, um, but has multiple layers, it usually has something repeated in the background. Um, you can also do a scrolling bitmap screen. This is better for a 320 mode. So if you want to have a scrolling high-res bitmap screen instead, then you can also do that. But yeah, um, this is how that works. Um, and if you want to go experiment with Legend of Naomi 2, um, you can figure out how to make it scroll. I actually, hang on, going back to Legend of Naomi 2, I believe I added section, the section which reads from RAM. So you can go see how that works. But yeah, um, that's everything.